Hello everyone. In the last video, we had done shape and geometry of molecules by the help of VSEPR theory. Today, we are going to do a shortcut method for finding out the shape and geometry of molecules without actually learning the examples or without actually remembering the examples. Okay, and that's called as VSEPR shortcut method. For doing the shortcut methods, first we have to remember this table. And in the VSEPR theory, we have done this table. We already explained this table, but quickly we will recall this. And this table you should learn and remember, and you should keep in front of your study tables so that you can recall it again and again. According to this table, if a molecule has two electron clouds, and both of the electron clouds, they are bond pairs. Both are bond pairs, no lone pair, then the shape and geometry of the molecule will be linear and bond angle 180 degree. Okay. Now if a molecule has three electron clouds and three bond pairs, zero lone pair, which is a regular geometry, trigonal planar, bond angle 120 degree. If a molecule has three electron clouds and the second condition is two bond pairs and one lone pair, the molecule will have angular V or band shape geometry, bond angle will be less than 120 degree. Unless you have to remember the bond angles, you need not to write the exact bond angles. You can write less than 120 degree and IB gives you marks for this. Okay. Now, next is if a molecule has four electron clouds. And out of this four, all four bond pairs, then the regular geometry will be tetrahedral, bond angle 109.5. Three bond pairs, one lone pair, then trigonal pyramidal, which is bond angle 109.5, less than 109.5. The bond angle decreases to less than 109.5. Three bond pairs, one lone pair. Now two bond pairs and two lone pairs, band shape or angular again, less than 109.5. In this case, you have to remember the bond angles of ammonia, which is 107 degree, and bond pair of water for this example, which is 104.5 degree. These you should remember. Now, if there are five electron clouds in a molecule, then condition number 1, 5 plus 0, that is all the five bond pairs, no lone pair. Trigonal bipyramidal, bond angles 120 degree and 90 degree. 4 plus 1, 4 bond pairs, one lone pair. Seesaw, sawhorse shape, bond angles are less than 120 degree and less than 90 degree. Now the next condition is 3 plus 2, that is when there are three bond pairs and two lone pairs. Out of the five electron cloud, three are bond pairs and two lone pairs. The shape becomes T shape and the bond angles are 90 degree and 180 degree. When the shape is T shape, the bond angles are 90 degree and 180 degree. This is 3 plus 2, 3 bond pairs, 2 lone pairs. Third is 3 plus 2 and the fourth is 2 plus 3. 2 bond pairs now and 3 lone pairs. 2 bond pairs and 3 lone pairs, shape is linear. Bond angle 180 degree between the 2 bond pairs. Okay, so this is for 5 electron clouds. When a molecule has 6 electron clouds, if a molecule has 6 electron clouds, then the condition number 1 will be 6 plus 0, all the 6 bond pairs, no lone pair. Shape is regular, octahedral or square bipyramidal. Bond angles 90 degree. If a molecule has 5 bond pairs and 1 lone pair, shape changes to square pyramidal, bond angles again 90 degree. 4 plus 2, square planar, shape is square planar. Okay, and the molecule is square planar shape, bond angle 90 degree. For 6 electron clouds, the molecule will have, next is for 6 electron cloud, if 6 bond pairs, all the electron clouds are bond pairs, no lone pair, octahedral or square bipyramidal geometry. Bond angles, all bond angles are 90 degree. If it is 5 plus 1, 5 bond pairs, 1 lone pair, square pyramidal geometry, all bond angles again 90 degree. If it's 4 plus 2, 4 bond pairs and 2 lone pairs, shape is square planar shape, all bond angles 90 degree. Clear? 7 electron clouds, pentagonal bipyramidal, 72 degree and 90 degree are the bond angles. So this is the table, and by the help of this table, you can remember the number of electron clouds and what will be the shape and geometry. You should draw this table on your own, or you can keep it on your table, in front of your study table so that you can remember it. Now what's the shortcut method? We are moving to the shortcut. If I want to find out, suppose the first molecule I want to find out the shape and geometry, which is the most common molecule, is PCl3. PCl3, I gave you the structure many times. What are the rules for finding out this rule number 1. Point number 1 is find the central atom in the molecule. Central atom in the given molecule. Now when you have to find out the central atom will be generally or basically the atom with least electronegative. Least electronegative element will be my central atom. Out of these two, we know phosphorus is least electronegative, therefore phosphorus is the central atom. Okay. Right, finding out the central atom. Next point is, after finding out the central atom, point number 2 is find number of valence electron on central atom. In this case, it is phosphorus, therefore the number of valence electron for phosphorus will be 5. Number of electron of phosphorus will be 5. I find it out, number of valence electron in phosphorus. After doing it, now the next rule is subtract the number of single bonds the molecule has formed. Single bonds or monovalent atoms. How many single bonds the molecule has formed? 3. So what I will get? 5. My 5 is my valence electrons. Therefore 5 minus 3, I will get a remainder of 2. Next rule is, after getting the remainder, divide the remainder by 2. If you divide the remainder by 2, you will get the number of lone pairs. So what I will get, this is my remainder, divided by 2, what I will get? 1. What the molecule has? The molecule has 3 bond pairs which are represented by the single bonds and 1 lone pair which I got by dividing the remainder by 2. Okay. Now the molecule has 3 bond pairs. I identified 3 bond pairs plus 1 lone pair. This is the PCl3 molecule has. When I have 3 bond pairs and 1 lone pair, according to this, 3 bond pairs and 1 lone pair is what shape? 3 bond pairs and 1 lone pair shape is trigonal pyramidal bond angle less than 109.5. So what I will write? I will write 3 bond pairs and 1 lone pair. The shape of the molecule will be trigonal pyramidal shape, and the molecule's bond angle will be, shape is trigonal pyramidal. And bond angles, since I don't know exact bond angles, so I will write 1 less than 109.5 degree, which is my regular, or we can say, bond angle of the 4 electron clouds. Now one more question, additional question which they ask you in this along with this is, what is the shape and geometry of the electron clouds? Shape and geometry of molecule is tetrahedral. Now shape and geometry of molecules, or we can say electron clouds. One more additional question they can ask you along with shape and geometry of molecule. What is the shape and geometry of electron clouds? How many electron cloud this molecule has total? Total electron cloud is 4 plus 1, that is equals to 5. Okay, now the next example, if I take an example of, suppose the next example of the molecule is NO3 minus. Now in this case, first I will identify the central atom. Central atom is nitrogen. Okay, as per the rules, identify the central atom, which is nitrogen. Valence electron on central atom equals to 5. Since a negative charge is there, a negative charge means you have to add. It has 1 negative charge, add 1 to this. Whenever we have a negative charge ion, for anion, you have to add the charge. Add the charge. What I will get? I will get total 6. Okay. Next important thing is, the molecule is combined with oxygen or bonded with oxygen, which is a divalent atom. For divalent atoms, we have to double the number of the atoms for subtracting from this 6. That is total electron clouds. Double the number of divalent atom, you have to double the number of divalent atom. Double the number. That is how many divalent atom? 3. Multiply by 2, 6. Subtract 6, what you will get? 0. It means the molecule has 0 lone pairs. But in order to find out the bond pairs, what we have to do? In order to find out the bond pairs, we'll divide this 6 by 2 because there is a divalent atom, that is 3. So what the molecule has? 3 bond pairs and 0 lone pairs. Thus NO3 has 3 bond pairs plus 0 lone pair. And for 3 bond pairs and 0 lone pair, or the shape and geometry of molecule, for 3 bond pairs and 0 lone pair, shape is trigonal planar, bond angle 120 degrees. So this will be the shape and geometry of the molecule. Bond angle 120 degree, and shape is trigonal planar. Trigonal planar, trigonal planar, and bond angle 120 degree, regular geometry for trigonal planar. Now one more example. If I take a molecule like NH4 plus, having a positive charge is a cation. Now first identify the central atom. Same rule. Central atom is nitrogen. Valence electron on this nitrogen 5. It's a group 15 element or 5 element. Valence electron will be 5. Now since it's a cation, so we have to subtract charge of the cation. What's the charge on the cation? 1. So we'll subtract 1, which is then the electron clouds will be 4. Now this is bonded by 4 bonds or 4 monovalent atoms. So I will subtract 4 from this, minus 4, I'll get 0. It means it will have 0 lone pairs, but 4 bond pairs. For 0 lone pairs and 4 bond pairs plus 0 lone pair. If I want to see the geometry and shape, 4 bond pairs and 0 lone pairs, 4 plus 0, tetrahedral. Tetrahedral will be the shape. This will be the shape and geometry of molecule. Bond angle 109.5 degree. 109.5 tetrahedral will be the shape of NH4 molecule. So I can say NH4 ion or the molecule has a tetrahedral shape, tetrahedral, and bond angle is 109.5 degree, a regular geometry and bond angle. Okay. Now the fourth molecule, one more example we do. Suppose a molecule 4, which is the common example, I3 minus if they give you. In this case, it's again an anion. There are 3 iodine atoms. One of the iodine will be my central atom. Okay. One of the iodine will be my central atom. Next, remaining 2 will be surrounding. Central atom valence electron are 7. Iodine has 7 valence electrons. Since it's an anion, we'll add 1 as per the rule. Total electrons are 8. Now out of the 3 iodine, 2 iodines are bonded with a central iodine by single bond, because halogen can form a single bond. Thus I will subtract 2 from this 8, I will get 6. 6 divided by 2 will give you 3. This 3 is the lone pairs and the 2 are the bond pairs. So what the molecule I3 minus has? 2 bond pairs plus 3 lone pairs. 2 bond pairs and 3 lone pairs. As per the geometry, 2 bond pairs and 3 lone pairs. 2 bond pairs and 3 lone pairs, 5 electron cloud geometry, and the shape is linear, bond angle is 180 degree. Shape linear, bond angle 180 degree. So I will write shape is linear, and bond angle 180 degree. This is the shape and geometry of I3 minus ion. If I take one more example, suppose I am taking example number 5, which is CO3 2 minus ion. CO3 2 minus ion, it's a carbonate ion, and they ask you to find the shape and geometry of carbonate ion. Now the central atom is carbon. How many electron carbon has? Valence 4. Carbon has 2 negative charge, add the 2, what you will get? 6. And oxygen is a divalent atom. Again, it is bonded to a divalent atom, oxygen. How will you find out? Subtract double the number of divalent atom, that is 3 into 2. I will subtract 6 from it, minus 6. It will get 0. It means the molecule has 0 lone pairs. And what about the bond pairs? Bond pairs will be 6 divided by 2, because the divalent divided by 2, the 3 bond pairs. What I will get? I will get 3 bond pairs and 0 lone pair. For 3 bond pairs plus 0 lone pair, the shape and geometry of the molecule as per this table, 3 bond pairs and 0 lone pair. If I see this table, 3 bond pair and 0 lone pairs, the shape and geometry is trigonal planar, bond angle 120 degree. Thus, the shape and geometry of the molecule will be trigonal planar. I will write trigonal planar, and bond angles are 120 degree. This will be the answer for this. Okay. In this way, you can find out the shape and geometry of any molecule without mugging them or without learning them by using this formula. I quickly revise it. First, find out the central atom, which is to be the least electronegative element. Then number of valence on the central atom, and then subtract the number of single bonds or monovalent atom. Number of monovalent or single bonds, I can say. Subtract, I will get 5 minus 3. That will give you a remainder divide by 2, you'll get the lone pairs. And these monovalent atom gives you the bond pairs. Thus PCl3 has 3 bond pairs and 1 lone pair, trigonal pyramidal geometry. Okay. Now, one more type of question which they ask you along with the shape and geometry of the molecules. They ask you what is the shape and geometry of the electron cloud. Shape and geometry of electron cloud. When they ask you the shape and geometry of electron cloud, then what you have to do, you have to find out the total number of electron cloud, that is sum total of bond pairs plus lone pairs. Suppose I talk about PCl3, how many bond pairs this PCl3 molecule has? 3 bond pairs. It has 3 plus 1, total 4 electron clouds. And for 4 electron clouds, as per our VSEPR theory, if I have 4 electron clouds, what should be the shape and geometry? 4 electron clouds I'm talking about. Regular shape and geometry is tetrahedral. Bond angle 109.5. Thus, I will write the shape and geometry of PCl3. The shape and geometry of PCl3 is tetrahedral in terms of electron clouds. So if they ask you what is the shape and geometry of a molecule in terms of electron clouds, irrespective of the bond pair and lone pairs, you have to calculate the total number of electron clouds, and the regular geometry of that total number of electron clouds as per VSEPR will give you the shape and geometry of the electron clouds of that molecule. Suppose we talk about I3 minus. We talk about I3 minus. Now, the total number of bond pairs and lone pairs, it is 2 bond pairs plus 3 lone pairs. Total number of electron clouds is 5. Now, for 5 electron clouds as per this table, 5 plus 0, what is the shape and geometry? Trigonal bipyramidal, bond angle 120 degree. What I will write? I will write for the electron cloud geometry for this I3 minus. The electron cloud geometry for this I3 minus will be trigonal bipyramidal. Trigonal bipyramidal. Okay. And bond angles, if they ask you, then 120 degree and 90 degree. Okay. But they generally ask about the shape. Electron cloud shape will be always equal to the sum total of all the electron clouds, that is lone pair and bond pairs, and the regular geometry of the lone pairs and bond pairs. Okay. I hope I'm clear. So in this way you can find out for any molecule. If you want, I can do one more. One more is, suppose NH2 minus I'm doing. NH2 minus, central atom, nitrogen. Valence electrons, 5. Negative charge, yes, add it, we'll get 6. Monovalent atom, yes, 2. Subtract 2, but you will get 4. Divide by 4 by 2, you'll get 2. What it will give you? It give you 2 bond pairs and 2 lone pairs. That is, NH2 minus have 2 bond pairs plus 2 lone pairs. So what is the shape and geometry as per 2 bond pairs and 2 lone pairs? 2 bond pairs and 2 lone pairs as per this will be angular or bent, 109 less than 109, 2 plus 2. Okay, so this I will write there. What is the shape and geometry? Shape and geometry will be angular or bent shape. Angular or bent shape. If they ask you about bond angles, then you can write less than 109.5 degree. Now, additional question. What is the shape and geometry of the electron cloud? Shape and geometry of electron cloud of NH2 minus. How many electron pairs? 2 plus 2. It has 4 electron clouds. And for 4 electron clouds, the regular geometry and shape is tetrahedral. So the molecule will have tetrahedral shape in terms of electron clouds, and actual shape will be angular or bent. I hope this will clear all the doubts. Without learning any of the examples for VSEPR theory, by simply remembering these rules, you can find out any shape and any bond angles of any of the molecule given. Thank you very much for watching. Now next video we're going to talk about shortcut of hybridization. Thank you.